level? No, I don't. As long as the compiler is willing to recognize that if I say, y equals x plus 5, and the compiler is willing to turn that into either a method call or a field dereference as appropriate, do I really care? The Scala authors will say, no, you don't. If you do care, it's because you spend too much time thinking about the physical structure of your code, and you're not spending enough time thinking about the problem you're trying to solve. So we use this very neutral term def to imply that we are defining a new name-value binding. Okay? And if we look at it, I mean, again, it's not all that hard to figure out. We just, after the code's compiled, Java P hello world, and there we see X, it's actually defined as a method. And sure enough, if we were to drill through all of the bytecode and so forth, we would see that this is backed somewhere either by a field that's going to hold the initial value of 12, or it's in fact going to be a method that just returns the constant value of 12. You can look that up later if you feel so inclined. The point is, the compiler is the one who made the decision that this should be a method, not a field, and I couldn't be happier, because it's one less thing that I have to worry about, and it's that many keystrokes that I don't have to type anymore. All that makes sense so far? Okay. Next. When you start working with functional languages, it's very common to see examples that are sort of steeped in mathematics. One of the very common examples is the calculation of factorial. Okay? Now, one of the interesting things about factorial is you can generate some really big numbers really, really quickly. So while we could have done this using traditional Java int, instead we decided to do this with the Java big integer class. Okay? How many people have worked with big integer? Couple of hands. Okay, very cool. One of the things that you discover very quickly about big integer is the fact that it does not support operator overloading. You've got to make method calls, which, is really where a lot of the calls, where Java has gotten pressure to introduce operator overloading, is from the math and science community, who say, God, it's a pain in the ass to have to call add, right? I.add parens some value, because it just doesn't feel right. We're used to saying I plus y, not I.add parens y. Now, in this particular case, again, looking at this code, what do you notice that's different? I'm using operators. Yeah, where? I'm using the function multiply. Yeah. I'm using it as an infix operation, right? Sort of, kind of, maybe. I'm not using the star character, right? But it certainly is, x multiply y. Wait, if that's a method on big integer, what's missing? Where's my dot? Where's my parentheses? Again, the Scala compiler is smarter than the JavaC compiler. It looked at that and said, you know what, I recognize that there is a method on that class called multiply, and the way you're using this particular sequence of text, I'm assuming you mean x dot multiply parens. And as long as there's no ambiguity, it's perfectly happy. Again, dropping punctuation where we still can make the intent clear. What else is missing? Or what else is different? You mean I'm not using the method equals? I'm using the operator equals, right? I mean, I'm using equals equals right there, right? There's something deeply recursive about what you just said. But I think I get what you're saying, right? I don't have to type dot EQUALS parens, right? I can use equals equals the characters, right? Now there's some interesting and subtle rules about how Scala treats equals equals versus dot equals, right? Identity versus equivalence comparison. But for the most part, Scala has done the right thing to allow us to do exactly this, the x equals equals 0. By the way, where did 0 and 1 come from? big integer, right? And being as how those are symbolic constants defined on big integer, right? In Java, how do I have to do this? I have to say big integer dot 0 or big integer dot 1 unless I do a static import, right? Which, by the way, requires syntax which is different from a traditional import. Why? Just because. I don't know why. They figured the Java compiler was stupid. I don't know. But notice, number one, where does my import statement occur? It's inside the object. Imports are now scoped. So I could do an import inside of any place where I have a pair of curly braces, and the import will last for exactly that long. Secondly, what am I doing with this import? I'm going to actually write some code while we're doing this. So I'm going to come back here. Oops. Come back here, and I'm going to do import big, java.math.big integer, like so. Right? This imports the big integer name into the top level namespace. But then notice back here on the slides I do something else. I then say big integer dot underscore. What this will do is effectively import all of the symbols present on big integer into the top level namespace. The underscore in a functional language acts as the wildcard. So in this particular case, you can think of this as import big integer dot star, which will be the equivalent of doing a static-based import. Okay? Now, def factorial. Now, earlier I was talking about, you'll notice I don't do it here, I was talking about that type inference. Factorial x equals if x equals 0, 1, else, let's see, x multiply fact x subtract 1. Okay? What am I missing here, by the way? What's that? I'm missing my curly braces. Why? Will this code compile? How many people think it'll compile? Let's try it. Oops. Because there's always the chance that I'm just like screwing with your heads and showing you stuff that won't compile. Nope, it compiles. Why? Because this is a value. This is a function value, but it's a value. And so therefore it can be assigned to a name, which in this case the name is factorial. Okay? And there's no implicit return, or there's no explicit return. Why? Because if else implicitly yields a value. In a functional language, every expression yields a value. And so one of the things you're going to have to get used to, for example, is the fact that this expression, because it's one expression, right, based on a decision early in the expression, I'm either going to yield this value or that value. Those values need to be of exact same type. The same is true with things like switch case and pattern matching in Scala. Okay? Now, let me come down here. And I'm going to try, let's see, system.out.println factorial 12 equals factorial 12. Will this compile? Let's see. Colon expected but right parens found. It's giving me an error with respect to factorial where it didn't before. Why? Well, because prior to this, factorial was never used. So the compiler said, no point in checking it. No point in figuring out if all of this stuff works. Now, this is not going to always be the case. But in this particular case, it just kind of said, if nobody's using it, I ain't going to spend a lot of time worrying about it. Okay? Now, when I attempt to use it, it's saying, well, I don't quite know what x is supposed to be. In other words, the type inference is failing us here. So I'm going to say x should be of type big integer. You know what? That's kind of a pain to type all the time, right? Big integer, capital B, capital I, especially when you compare it to something like int, right? So what I'd like to do is I'd like to rename big integer. I'm going to call it bint. Makes a certain amount of sense. So let's see. I'm going to